Hello everyone, welcome to course study on solid mechanics. As we are in unit number 5, that is principal stresses and strain. So our today's topic of discussion is normal and shear stresses on an oblique plane. So in this topic we are going to calculate, or we are going to find out the value of normal stress and the shear stress which are acting onto the oblique plane. Okay, so to find out that particular value, we have to concentrate on a rectangular section ABCD of uniform cross-sectional area and of unit thickness. Okay, so as per the given statement, we have to concentrate on rectangular section ABCD of uniform cross-sectional area, and the thickness is unit 1. That is, it is a thickness which is perpendicular to the plane of the paper. Okay, and that thickness is unit 1, that is one value of thickness. Okay, so from the figure we have sigma x, this is the sigma x, again this is the sigma x. So sigma x is equal to tensile stress acting in x direction over the face AB and CD. So this is face AB and this is face CD. On those faces, the value of sigma x, which is tensile in nature, is acting. Okay, in the same manner we have sigma y also. Sigma y, this is sigma y and this is sigma y. Okay, which are acting on face AD and face BC. Okay, and those sigma y, it is also tensile in nature. Therefore sigma y is equal to tensile stress acting in y direction over the face AD and BC. Okay, this is shown in figure. In the same manner we have tau is equal to shear stress acting on rectangular section ABCD, very important one. Okay, so this is the value of tau which is acting over face AB. Okay, this is the value of tau which is acting over face BC, tau on CD and tau on AD. Okay, so this particular direction, that is a positive phase, and the negative direction will be considered as a positive shear stress in today's discussion. So those are the values of shear stresses acting on faces of AB, BC, CD and DA. Okay, now we have to concentrate on an oblique or inclined section AE which is at an angle of theta with the normal face of plane AB. So as per the statement, we have to concentrate on an oblique or inclined section AE. So this is an inclined section AE. Okay, which makes an angle of theta with the normal face of plane AB. So this is the normal face of plane AB. So with respect to this vertical, it makes an angle of theta. Okay, so remember that we are going to find out the value of normal stress and the shear stress on an oblique plane for this particular given set of condition. That is, the shear stress is acting in this manner. Okay, again in this manner. The value of stresses sigma x and sigma y have considered as a tensile one, and the value of theta, it is with respect to the normal face of plane AB. So you have to remember it, and for those condition, for those given set of condition, we are going to derive the value of normal stress and the shear stress on an oblique plane. Okay, if in numerical the value is opposite to this particular set of given condition, then we have to change our sign also. So that concept we will discuss through the concept of numerical. Okay, so our today's aim is to find out the value of normal stress and the shear stress. Okay, so this is value theta. From that we have to concentrate on a wedge or triangle ABE. Okay, so this is the triangle ABE. Okay, and we have separated that particular triangle in this manner. So this is the separated triangle. Okay, on this particular triangle, if you observe carefully, the value of sigma x is acting, the value of sigma y is also acting, the value of shear stress is also acting on AB and EB. AB and EB. Okay, now our aim is to find out the value of sigma n, okay, which is acting perpendicular to the oblique plane AE. Also we have to find out the value of sigma t, that is a tangential stress which is acting along the plane AE. That is our aim. Okay, and this is theta. So we have in this manner we have concentrated on triangle ABE. Okay, and if you observe carefully, there are 6 forces acting over the triangle ABE. Those 6 forces are in term of normal stress or in term of shear stress. Okay, so we will discuss this concept further. So the forces acting on face AB of triangle ABE. Remember that there are 6 forces acting on triangle ABE, and those forces are in term of normal stresses and shear stresses. Okay, so the first one is forces acting on face AB of triangle AB. So this is face AB. Okay, and for that particular face AB, we have to find out the value of forces which are acting. Okay, so the first force for face AB is force due to the tensile stress sigma x. Force due to the tensile stress sigma x. All of you know that stress is given by force upon area. So how to calculate the value of P? P is equal to sigma into A. Okay, so in this manner we are going to find out each and every force, either in term of normal stress or in term of shear stress. Okay, so the first one, as discussed earlier, force due to the tensile stress sigma x is equal to sigma x into AB, because sigma is equal to force upon area. Therefore force is equal to sigma into area. Now why we have considered only AB? Because the thickness of AB is unit 1 and it is perpendicular to the plane of the paper. Therefore we have not multiplied here by 1 because it is unit thickness. Therefore the force due to the tensile stress sigma x is equal to sigma x into AB. In the same manner, the force due to the shear stress tau is given by tau into AB. Okay, again the thickness is unit. Our third force is forces acting on face AE of triangle ABE. The forces acting on face AE of triangle ABE. So this is face AE. Okay, so the force due to the normal stress sigma n is given by sigma n into AE. Okay, again the thickness is unit 1. The force due to the tangential shear stress, that is tangential stress sigma t, is equal to sigma t into AE. Okay, so in this manner we have found out the value of 4 forces, and remaining 2 forces we are going to find out. The forces acting on face BE of triangle ABE. So this is face BE. Okay, on those face whatever the forces are acting, that we are going to calculate. So the first force for the same is force due to tensile stress sigma y is equal to sigma y into BE. Again the thickness is unit 1. Force due to the shear stress is given by tau into BE. Okay, so in this manner on triangle ABE we have find out these 6 number of forces in term of normal stress and shear stress. Okay, now we are going to show all those forces on this particular diagram in detail. Okay, now as those are the forces acting over the triangle ABE, we have to resolve the above forces along the oblique section AE and normal to the oblique section AE. Okay, so we have to resolve the forces which are acting on oblique section. Okay, it may be normal or it may be tangential to the oblique section. Okay, so let us consider the forces acting normal to the oblique section and we will have the following equation as mentioned here. So the first equation which we have to consider is the forces which are acting normal to the oblique section, that is the forces which are acting along this direction. The forces which are acting along this direction we have to consider, and we have to make the algebraic sum of all those forces. Okay, therefore sigma n ae is the first force. Okay, and that force is equal to the sum of all the forces, algebraic sum of all the forces which are acting along this direction. Okay, therefore we have sigma n ae is equal to sigma x ab cos of theta. So this is sigma x ab cos of theta, this force. Is it okay? Plus tau ab sin of theta. Now we have resolved this particular force, tau ab sin of theta. Shear stress has resolved into its component. Okay, plus sigma y be sin of theta. Sigma y be sin of theta means this force we have resolved into this component. Okay, and the last force is tau be cos of theta. Tau be cos of theta means this force, means a shear stress has resolved into its component. Remember that those cos of theta, sin of theta, now it's a concept of trigonometry. Okay, all of you discuss the concept of trigonometry in 11th, 12th or in first year also. Okay, so by resolving the forces we have find out the values. Okay, this angle is theta, this angle is theta, therefore this angle is also theta. It is by the concept of trigonometry. Okay, if you require you can solve for, you can check it whether it makes an angle of theta over here, whether it makes an angle of theta over here. If you require you can check it. Okay, so as per the trigonometrical consideration it makes an angle of theta at those point. Is it okay? So it's a concept of trigonometry. So from this equation we have sigma n is equal to sigma x into ab by ae cos of theta, because this ae will divide to all those equation. Okay, therefore sigma n is equal to sigma x into ab upon ae cos of theta plus tau into ab upon ae sin of theta plus sigma y into be upon ae sin of theta plus tau into be upon ae cos of theta. So what we have done for this equation, we have divided by ae. Okay, after dividing by ae we have this particular equation. Okay, now again we will solve for the given equation. So we will have sigma n is equal to sigma x cos of theta into cos of theta, because ab upon ae is nothing but it is the value of cos of theta. Okay, adjacent side divided by the hypotenuse. Okay, ab upon ae. In the same manner we have tau into cos of theta into sin of theta. Again ab upon ae is nothing but cos of theta. Sigma y into sin of theta into sin of theta, because be upon ae is nothing but sin of theta. From this figure you have to calculate all those values. It's very easy because it's a concept of trigonometry. And the last one, tau into sin of theta into cos of theta. Again be upon ae is nothing but it's a sin of theta. So in this manner we have the value of sigma n in the form of this equation. Is it okay? Again we will rearrange the equation in the following manner. If you rearrange the equation we will have sigma n is equal to sigma x cos square theta plus sigma y sin square theta plus 2 tau sin theta cos of theta. Is it okay? This value, this equation we have from this equation. Okay, therefore After making some mathematical simplification, after dividing by 2, multiplying and dividing by 2, we have sigma n is equal to sigma x upon 2 into 2 cos square theta plus sigma y by 2 into 2 sin square theta plus 2 tau sin theta cos of theta. It's a mathematical simplification. Okay, now sigma n is equal to sigma x upon 2 into 1 minus sin square theta plus cos square theta, because this is the 2 cos square theta. 2 cos square theta means it is cos square theta plus cos square theta. So all of you know that sin square theta plus cos square theta is equal to 1. Therefore cos square theta will be equal to 1 minus sin square theta. So this is the value of cos square theta only, and the another cos square theta will remain as it is. Okay, plus sigma y by 2 into 1 minus cos square theta plus sin square theta, and the last one plus tau sin 2 theta, because 2 sin theta cos theta will be this sin 2 theta. Okay, so this is the answer for this one. After solving this equation, we will have sigma n equal to sigma x plus sigma y by 2 plus sigma x by 2 cos of 2 theta minus sigma y by 2 cos of 2 theta plus tau sin of 2 theta. Okay, and again solving for this equation, we will have the last answer, final answer for the normal stress on oblique plane, that is sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos of 2 theta plus tau sin of 2 theta. This is the final and last answer for the normal stress on an oblique plane. Okay, remember that we have derived this particular equation on the basis of this given set of condition, that is sigma x will be tensile, this tau is acting along this direction, this tau is acting along this direction, in this manner. For this set of condition, we have derived the value of sigma n for this one. Okay, if any one value, if any one values of sigma x, sigma y, tau changes its sense, the value of sigma n also changes in the given set of condition. Okay, so this is the value of sigma n. Now we are going to find out the value of sigma t, that is shear stress which are acting onto the oblique plane. Okay, now consider the forces which are acting along the oblique section, and we will have the following equation as mentioned here. Now we have to consider the algebraic sum of all the forces which are acting tangential along the shear stress of the oblique plane. Okay, therefore we will have sigma t ae. Remember that sigma t is nothing but it's a shear stress which are acting along the oblique plane. Okay, sigma t into ae is equal to sigma x ab sin of theta minus tau ab cos of theta minus sigma y be cos of theta plus tau be sin of theta. Okay, so minus and plus sign is nothing but all the forces which are acting along this direction we have considered is as a negative, and all the forces which are acting along this direction will be considered as a positive. If you require, you consider any sign convention. Okay, so I have considered the sign convention in this manner. Okay, so again solving this, again dividing by ae to this equation, we will have sigma t is equal to sigma x into ab upon ae sin of theta minus tau into ab upon ae cos of theta minus sigma y into be upon ae cos of theta plus tau into be upon ae sin of theta. Okay, again by using trigonometrical consideration, we have sigma t is equal to sigma x cos of theta sin theta minus tau cos of theta minus sigma y sin theta cos theta plus tau sin theta. Okay, so on solving this equation, I have sigma t is equal to sigma x minus sigma y sin theta cos theta minus tau into cos of 2 theta plus tau into sin of 2 theta. Okay, again solving for this equation by making some mathematical simplification, I have the final value of shear stress which is acting along the oblique plane, that is sigma t is equal to sigma x minus sigma y by 2 sin of 2 theta minus tau cos of 2 theta. Remember that again I am saying all those values which we have found out, those are based on the given set of consideration of sigma x and the shear stress. If any value changes its sense, then the formula will change according to that particular sense. Okay, so in this manner we have determined the values of normal stress and the shear stress which are acting onto the oblique plane. Okay, if you require for the numerical point of view, you will only remember this equation. You have to remember only this equation, no need to go through entire derivation. Okay, for the purpose of solving numerical, you only concentrate on this equation only and this equation only. You remember only these two equations, no need to go through the derivation of it. For the sake of understanding, I have derived this particular equation. Okay, but for you no need to go through the derivation, only remember the formula of sigma n and sigma t. Okay, so in the next lecture we will discuss the concept of orientation of principal stresses, shear stresses and its magnitude. Orientation means the direction of principal stress and the principal plane, and we are going to find out the magnitude for the same. Okay, so we will stop here. Thank you.